Hey, my name's Brent. Welcome back to the TPR 86cc build series. So in one of my recent videos, I was trying to get this scooter ready for an upcoming car show. And the main concern for me was making sure it was reliable, as well as in a good state of tune. So related to reliability, I replaced my old TPR 86cc cylinder kit with a brand new kit exactly the same. The main reason that I did that was I had some concerns about the cylinder head. Here's my old cylinder head, and if you look in this area and this area, you can see the problem. So the way this is supposed to be set up is that the bore has its own O-ring, and then each one of the cylinder studs has its own O-ring. And they're all supposed to be separate of each other, just like these areas. There's supposed to be material between each of those O-ring grooves. And this one was originally like that, but after some miles, when I took it apart, I found that this was chipped off. These very thin walls were chipped off, and it looks like there was some sort of shift, and these were not bored perfectly on center as they should be. So it appears that these walls were very, very thin, and these were a little thicker than normal. And when I got my new TPR kit, I found that they were all just thin. They weren't as thin as these were, and they weren't as thick as these were. They were somewhere in between, but they were all really thin, and it just seemed to me like a design flaw. So I was wondering if that could be remedied. This is one of the stud O-rings that comes with the TPR 86cc kit, and by my measurements, which aren't going to be perfect because there is some squish or compression involved in these O-rings, it looks like about a 1.75 millimeter cross-sectional diameter or thickness of that O-ring, and it appears to be an 8 millimeter inside diameter, so it's meant to go around something that's 8 millimeter. If you take those numbers together, that comes out to mean it's about an 11.5 millimeter outside diameter, which matches up with what I measured in these O-ring grooves in the head. They are about 11.5 millimeters. So you can see that fills up the entire groove just like you'd expect. And that seems great, except as long as you've got an O-ring that big, you don't really have a lot of room to have any kind of material thickness between this bore O-ring and that O-ring. Some time ago, and actually I still am considering putting O-rings around the studs for one of my liquid-cooled 54mm kits that's on my 103cc engine. And because of that, I happen to have 3 O-rings around that may be appropriate for this. So this first one is a 1.5 millimeter thickness or cross-sectional diameter with an 8 millimeter inside diameter, which makes it about an 11 millimeter outside diameter. So it's basically the same as this, but a 1/4 of a millimeter thinner, the actual O-ring material. Unfortunately, that 11 millimeter outside diameter doesn't really solve a lot because that's only a 1/2 millimeter different as far as the outside diameter, and it won't give me a whole lot more room to add any material there. To me, I don't think it's going to be worth doing a lot of work just to get that. It might be plenty, but I'd really rather not go through that for that kind of difference, about a 1/4 of a millimeter right there on that edge. Then I have a 2 millimeter, so a little thicker than this, cross-sectional by 7 millimeter inside diameter, which makes it also 11 millimeter outside diameter. And the reason I think I should be able to use a 7 millimeter is because the studs for this do measure 7 millimeter, so I think that should be fine. But again, it gives me that 1/2 millimeter, and I'd like to have a little more room if possible. Which brings me to the last O-ring I have here, and this one is also 7 millimeter inside diameter, but it is a 1.5 millimeter thickness or cross-sectional diameter. So when you look at that, that is 10 millimeters outside diameter, and that gives me 1.5 millimeters of difference versus this one. So you can see, just looking at it sitting in this groove, I would be able to cut a significantly smaller groove in there and really create some room and some thickness between those two, even if this is off center a little bit. The first challenge here is that somehow I've got to have these areas filled so that I can recut them smaller for the smaller O-rings. My first thought with this would have been to take this to a professional welder and have them TIG weld it to fill those areas up for me, because I don't TIG weld, I don't even MIG weld aluminum. However, I've actually kind of been through this in the past. I wasn't doing the exact same thing, but I did want some grooves filled in the 103cc cylinder head that I had, and I took it to a professional welder right down the road from my house and asked him to TIG weld it. He took a look at the head. He saw some of the thin walls around the O-ring grooves and thin details, small details in the head, and he said that in his opinion, it would be better to try and use an aluminum filler rod or brazing instead of trying to TIG weld it, because he thought it would put me at less risk of warping or melting the head, melting parts of the head. So that's what a professional welder did for me, and it actually did hold up to heat in that application. So I think that's what I'm going to do myself. That might give me the opportunity to fix this without even having to take it anywhere and get any help with it. So with that said, member Rick Cooper commented on one of my videos and actually linked me to a Project Farm video where they were reviewing aluminum filler rods and said they're not all created equal, so check this out. I watched that and also looked up some other reviews, and based on that I decided to go and pick up these Hobart 1/8 inch aluminum filler rods. And I'll put a link to these in the description in case hopefully they will work out for me and you want to check them out yourself. They melt at around 700 degrees Fahrenheit, and that should give me about 500 degrees before the actual aluminum of the head starts to melt. So hopefully, if I can keep close to that temperature, I won't mess too much up. With that said, I'm going to try to use just this simple torch setup with MAP gas instead of propane, because MAP gas burns a little bit hotter. I do have an oxygen MAP or oxygen propane setup. I'm going to try not to use that if I don't have to. Again, because that will make it a little easier to control and keep me a little further away from the melting point of the aluminum. I'm hoping to not mess anything up if I don't have to. Ideally, I would like to just melt these brazing rods and not melt any part of my head. So this is all new for me. I've never done this before, but I'm hoping that this will allow me to fill up all of those grooves. The head has been cleaned thoroughly, and then I set it up in the vise. As you can see, I tried to level it out. The main reason for that is I'm hoping it might save me a little time later, because if I can get a nice even puddle there instead of having a big glob on one side because it was uneven, then it might be a little easier or less time cleaning it up later. So according to the instructions, I want you to apply heat to this and then brush the area to be repaired thoroughly in order to remove any oxidation. So I'm going to go ahead and put some heat into it again with this MAP gas torch, and then I'll go ahead and brush over it. Now I'm going to try to put more heat in there and apply the filler rod. And what you're supposed to do is to heat the base metal and not heat the actual filler rod. So you want the base metal to be hot enough that the filler rod melts on it. So normally what you do is you heat this up and then you kind of touch or rub the filler rod against it until you start to see it melting. I'm not sure if that's going to turn out exactly how I need it to, if it filled all the way down in the O-ring groove, but while the head is still retaining some heat, I'm going to try and do some of the other grooves as well. I thought that went pretty well on the first, and then the second one. The third one wasn't too bad, but it started to cave in the center. These kind of held their surface tension or whatever, and they sort of stayed flat. I'm not sure if they sunk into the O-ring grooves all the way or not, but at least they stayed flat. This one caved in the center a bit, and then when I got to the last one, it really started caving in, and I couldn't get it to fill. What I think might be the problem is that I had too much heat applied by this point. So this one I did kind of on its own a little bit, then I waited a bit and started this. Then I continued to heat it and did this one, and continued to heat it and did this. So I think I was heating the entire head, and maybe the rest of the bore here where it's drilled for the stud was hot enough that it just continued to melt and fell down in there. That's where this chip came from. That had fell all the way through, and it's basically filled that bore up now. So I'll have to deal with that. But I'm thinking if I let this cool down, basically back to room temperature, or 100 something degrees anyway, and then reheat this area, maybe I can get it to just fill this top area like I wanted. I went over it once more, and I got a better result this time. I think I may have figured out a small trick to this. So initially what I was doing, I wanted the filler to be in the O-ring groove, so I would just push right in the O-ring groove area and try to fill it. Just seemed natural to me, that's what you'd do. But it kept caving in, it kept pouring all the way through, especially on this one. So what I ended up doing was pushing on the cylinder head surface right on the outside edge, and when I did that, if it would melt there, then gravity would do the work for me, and it would kind of flow into there and start to fill that up instead of everything just caving in. So I think that may be a small trick if you're having trouble with doing something like this. Maybe try letting gravity do the work for you. It's cooled off now, so here's what the other side looks like. And this was the first hole that I did, and not a whole lot ran down inside of the stud hole. All the rest, it filled them up pretty well. I didn't really want it to, but that's what it did. Broke off some chunks that were in there. But if you take a look at this, you might notice something kind of bad that's happened. So this is now oblong. Even the spark plug threads look oblong, so they're longer this way than they are this way. And I had this clamped in the vise just like that. What I have to imagine happened was, had it clamped in there, I heated it up, and after it was heated up for a while, I noticed when I looked at it that it was very loose in the vise. Didn't think anything of it, and I tightened it up more. And apparently I disformed it when I tightened it up because it was so hot. It was very easy to do that, and now it's out of shape. So clearly the spark plug threads won't work, and now this won't fit into the other section of this modular head. The sealing surface, I'm guessing, probably isn't that far off for the O-ring, but I'm hoping maybe what I can do, the only fix I can really figure that might work, is to heat it back up, and it was clamped here, instead clamp it here, and hope that I can get it somewhere close. It definitely didn't go back to being round, it's more square now. The only good news is it will at least fit into the head now, but you can see even the spark plug threads look square on this end, and it's not going to thread into there. However, if I flip it over, spark plug threads in just fine. Feels good until it gets about a little less than a 1/4 inch from the end there. So maybe there's some hope with the length of the spark plug threads, the reach on this plug. If I can get it just to fit into here, then it should be able to seal, hopefully. If nothing else, it'll have a good seal a little further down in there. Not at all ideal, but I don't really know where to get another head to start over, and I don't want to mess up the one that's on the scooter now, because if I mess that up not knowing where I can get just a head, then I've got to buy another whole cylinder kit. So I'm going to try to work with this one and see what happens. Time will tell how it actually works if I can get the rest of this stuff finished, but I think the threads have at least a chance of being alright now. If you look down here, you can see this area is deformed upward into the O-ring groove, and I checked and the O-ring is actually small enough that it fits in there just fine, but I would rather cut this flat again if I can. On the top side, it goes upward as well, so it's fine over here, but there's a bit of a ridge here or a mound there, so it's not totally flat across the top there, and I may go ahead and cut that down flat, just enough to get it flat to make sure the spark plug can seat against there well. So I cut this flat again. I made a tool up that's the same width of this O-ring groove and cut in there to make sure it was in good shape all the way around. And while I had this in the lathe, I went ahead and took off all this big chunk of material that was sticking out of here. I basically went in just until it was kissing the other surfaces here on the top of those. You can see it didn't even contact all of the other surfaces because I didn't want to really remove any material. It certainly hasn't gone perfectly up to this point, but it really went south when I tried to re-drill the holes for the studs. So on this side it doesn't look awful, but when you look over here, you can clearly see that some of these, or especially one of these, is very far off. These two are pretty close. They should be about where they need to be. This one's a bit off, and then this one again is way, way off. So what happened was, a lot of these were left with kind of a hemispherical top, a rounded top to them, or a dome. And I tried to center drill, or center punch, and then center drill them in the press, but regardless of what I did, I spent a lot of time setting them up, and every time I did it, they would kind of just veer off. The drill bits would go to one side or the other a little bit. To straighten out the bad ones, I would basically have to refill the entire area and then re-drill it. And I was concerned the first time around of trying not to get any more material filler dripping through than I had to. However, looking at them now, I think it would have been way easier for me if I had a flat surface on all of these. Those I could get started straight. So I probably should have just let it fill the entire area and just planned to recut the stud passages and the O-ring grooves on both sides. And I think I probably would have been better off. I started to wonder if it was even worth trying to go through all of this, because I have a brand new cylinder on there right now that I use for 281 miles with tuning and then going to the car show. And if that cylinder head that has been modified, I cut it back about 0.3 millimeters to improve squish. If that cylinder head comes off of there and nothing is wrong with it, then maybe it's not a big deal. Maybe it's just something that happened to me because that last cylinder head that I had was cut off center. So I wanted to take this engine apart. I was going to switch back to the old cylinder anyway, so I wanted to take the engine apart and see how it came out. Unfortunately, when I removed the cylinder head, I found that 3 out of the 4 O-ring grooves had a broken wall right there on the inside up against the other O-ring bore. And when I looked it over, I saw that the chunks of aluminum from those walls were actually still stuck to the O-rings. Now this cylinder head was not bored or drilled off center like my old one was, so it didn't have any noticeable issue. However, it still broke 3 out of the 4 cylinder walls. So clearly this must be an issue. The only thing that's kind of confusing to me is I haven't really heard anyone talking about this happening, and it's hard to believe that I'm the only person that this happens to. Obviously, I have been shaving the cylinder heads down. One I removed about 0.25 millimeters, and the other I removed roughly 0.3 millimeters. However, I haven't changed the thickness of that wall. I've changed the depth of that wall, but not the thickness, and I wouldn't think that changing the depth of that would really have a great influence on whether it failed or not. I'm not exactly sure. The only time I've had this thing together when the walls didn't break was the first time I actually used the kit. It lasted 1,000 miles. When I took it apart, the walls were still intact. I hadn't modified the head at that point, so it does kind of seem to show me, just by the only data that I've collected, that perhaps that does have an effect on it. However, I really don't understand why it would matter that much because you've still got that very thin wall thickness no matter how deep the O-ring groove is. Before I even took the engine apart to discover this, I had already got in touch with the guys at scootertuning.ca, which you should already know by now is my go-to place for scooter parts, so definitely check those guys out. I was trying to see if they could special order me a new cylinder head because I wanted a cylinder head in good condition for both my newer cylinder kit and my older cylinder kit. That way if anything failed, I would be sure that I could just bolt that right on and get going again. But I got really lucky and they had actually just listed this cylinder head kit in their used parts section. Apparently it came off of one of their engines. So for less than $50 shipped, I got this in just a couple of days and it's in great condition. So I was thinking as long as I had a head that was intact, I could try to put a steel rod through the stud grooves that fit pretty tight in there and just fill around that steel rod with the aluminum filler. Then I wouldn't have to go through all of the re-drilling process. My only concern was I'm not sure if the aluminum filler rod, the brazing rod, will actually stick to the steel at all and become a problem. So I was going to test that on this old head that I had already messed up before I tried it on anything else. I also had the thought of what if I made a steel rod that went through here and it had the section to fill everything that I wanted to leave open. So it would just leave a little bit of the outside diameter here and I would actually be filling exactly what I needed to, and hopefully I could just take the rod out of there and it would be basically ready, almost like cast in place, to create the new O-ring grooves that I needed, possibly with just a little bit of cleanup. But I didn't get that far. After discussing this with the guys on the forum for a little bit, I decided that I wanted to try to fix up this cylinder a bit more simply, or actually quite a bit more simply, than trying to refill the cylinder like I did with this one. I may end up resorting to that. We'll see how this goes. But first off, Scott, that's Old Geek on the forum, suggested that maybe I could just wrap some shim stock around the O-ring groove there on the outside, just enough to create the proper space to hold the smaller O-ring, and perhaps that would be sufficient. Which, not a bad idea. However, I do think it would be kind of tough to get it to the right height, because I'd really like it to be a matching height to the O-ring groove to make sure everything was sealed between there. And also, shim stock sometimes is not the most fun thing to work with. I could probably roll it around there pretty well, but you'd have to do that every time it was assembled, and I was afraid that might be a little difficult and maybe one of those things that could fail during assembly, and then you got to go back and redo it. Then Ken Ho came along on the forum and suggested maybe you could make some sort of insert that would be a light press fit into there that had the right inside diameter for the O-rings that I want to use. So I'm going to try to do that. These are about 452 thousandths of an inch, roughly. They actually range. The smallest one is 451, and the largest is 454 thousandths, measuring those, which is roughly 11.5 millimeters. So I'm going to make up, or try to make up, some aluminum rings to go in here with a 10 millimeter inside diameter to match up to these O-rings, and then just 1 or 2 thousandths larger than the diameters of these. So probably, I'm not going to cut all four separately, so probably what I'm expecting is it'll basically fall into one and the others will be light press fits. Not sure if it's going to work with such a small amount of material, but let's see what happens. I made up 5 of these. Obviously I only need 4, but I had enough material there where I drilled in to make up 5. Figured it'd be good to have a spare anyway. And I was able to just drill those with, I believe it was a 25/64 drill bit, and they actually came out right at 10.0 millimeters when I measured. So I didn't have to go through any boring operation. And then I just cut the outside down to the diameter that I wanted and parted them off. Now they are all parted much longer than what I need, or much thicker than what I need. But I'm hoping that what I can do is get those in place, and then if they are tight enough, maybe I can mount the whole thing in the lathe and then cut them all down right to match the depth that they need to be, right with the top of the cylinder head, the deck of the cylinder head. That way it goes all the way from the bottom to the top of the groove. Now in some of these grooves, they are not fitting very well. I mean, they fit close. It's like a snug drop-in fit, but they're not going to stay if I spin this thing in the lathe. There's no way. So what I'm hoping is I can use some retaining compound, some green Loctite thread retaining compound, and let that set up. I'll give it probably a day, and if it will hold that well enough, then I'll put it in the lathe and try to cut those down. But also, you can see that's a good fit for the O-rings that I have. It's been about 18 to 20 hours, and it seems like this has cured or set up pretty well. Everything seems to be secure. We'll find out if it's actually secure enough that it stays in place when I try to cut it. As you saw, that didn't exactly go as planned. One of them stayed in the head, and I managed to get that shaved all the way down. It doesn't look too bad, but the other three popped out. So I think there's multiple ways I can approach this, but I think I'm actually going to try to recut these and see if I can get them to be a tighter fit in there, because it doesn't take too long just to bore those out and cut the outside diameter. I cut out a group of these. I believe I should be able to get about a 2/1000th of an inch interference fit out of those, and that may be too much. I'm almost expecting that if I try to press these in or tap these in, it's going to crack or distort the rings. Actually, the very first one that I tried to cut, it cracked just from the pressure of trying to part it off. But I'm going to see if I can get those into the head. That went better than I thought, though not as well as I had hoped. So they pressed in pretty well. Wasn't actually that difficult. Nothing cracked. But the one that had stayed in there before was the one that was intact. It hadn't broken through the wall. All of the other three had broken through the wall to the other O-ring groove. And when I pressed all of these in, you can see kind of a triangular shape on one side, where they expanded into that area where the wall broke. So they're not concentric. I'm hoping that that doesn't matter. And I do think they're definitely tight enough that they shouldn't come out when I try to machine it. So I'm going to go ahead and try to just shave these down even with the head. It looks pretty good to me after machining. I went over it with sandpaper and tried to polish everything a bit, largely to make sure that there were no sharp edges here where the O-ring grooves are, because I don't want those to cut the O-rings. But the O-rings seem to fit in place pretty well. And all of these grooves are cut to 0.95 to 1.0 millimeter depth for a 1.5 millimeter thickness O-ring, and that should be acceptable. I will put a link in the description to a PDF that I found quite a while ago. I believe it was from an O-ring manufacturer, but it's got more information than you would probably ever want about O-ring fit. I took a quick ride to get everything up to temp, and then I retorqued the cylinder head nuts and checked the exhaust fasteners. I also went over after that and removed the spark plug, and I didn't see any signs of coolant on the spark plug. I didn't notice any excessive smoke or steam from the exhaust, although it would be kind of hard to tell unless it was a very aggressive leak, because this thing does smoke quite a bit. I run a heavy oil mix and it usually runs rich. And I also checked my radiator level, and it doesn't appear that my coolant level has dropped, so hopefully, at least for now, the new O-ring setup is sealing. This is going to be something I'll have to do some more rides, put quite a few more miles on there and see how it goes, so I'll have to update you on that in the future. Also, I haven't really talked about it in this video, but in the previous videos, I did a repair of the mount on the engine for the water pump. That seems fine so far, nothing's moved around, but again, I'll have to update you on that in the future if anything changes. So with that said, I'm going to end the video. Make sure you subscribe so you can see any updates that I do provide, and click the bell to receive notifications. If you enjoyed the video, found it helpful, entertaining, whatever, please give it a like, a thumbs up, and thank you for watching.